All right, so slightly related rules to the basic rules that we learned Thursday, and these rules will actually end us up finishing the basic rules. So I think we had this, right? And who's my go-to person in this class? I forgot. Oh, Mike. How about this?
That's ln, isn't it? When you do it. No, that's when you do ln of 2 to the x. Ln is 5 to the x. E to the ln of 5. What?
Well,
no, yeah.
All right, let me. What's the wrong answer?
X is 5, x minus 1.
No, I know that's definitely wrong. What's 5 to the x is wrong. 5 to the x plus c is wrong because if I took the derivative of 5 to the x, you'd get 5 to the x times ln of 5. So that's a problem. We're off by that ln of 5. So my question to you is, how can we remedy that chain? 1 over, not 1 over x. Not 1 over 5.
1 over 2x.
Nope.
ln x. ln x. ln 5x.
Well, now we're just guessing.
Oh, no, it's ln 5.
Yeah.
Oh, so close.
If I multiply by 1 over ln of 5, then when I chain on the ln of 5, the natural log of 5 and the 1... Yeah, I do win. That's nice. I like that. The natural log of 5 and 1 over ln of 5 will cancel out. Okay? Let's generalize that rule. Who is that? All right. So to generalize, does she need anything? Okay.
So is this basically the same thing as
Yes. Talk to me, Jack. Go ahead, talk me through it. All right, fine. Jack says, look, if we want to generalize, it's the same exact thing. If a is a constant, we end up with 1 over ln of a times a to the x plus c.
Yes.
All right? That's a rule. And you can see that that's actually very similar to our e to the x rule. As a matter of fact, if it was e to the x, it would be 1 over ln of e. What's the ln of e? Which is 1. So it really is an extension of the e to the x rule. Sorry.
The other one has product. Yeah, we can call this Christina. Tangent! X.
Good.
I was like, what is she talking about?
Mike?
Plus C.
How in the world did you know that?
Where's Mike? I remember. From the derivative.
Yeah, that's the only way to know that right now is sort of to memorize the fact that, well, what was the derivative of tangent x last semester? 1 over cosine squared x. Okay. And I have one. Okay, don't do that. One more rule, which is I think the only way I can get you there is by working forward. So I'm going to start with a function, and that function is going to be the natural log of negative natural log of the cosine of x. It's not a proof, but it's going to be a convincing argument by the time we're finished. So the derivative of the natural log of a function, what's the derivative of, what's the natural log rule?
1 over x. No, but if it's negative, it's 1 over x. Isn't it 1 over cosine x? And then you have to,
Okay.
tie in,
The natural log rule is 1 over.
Yeah.
And I have a negative sign out in front, so I can't forget the negative. But then I also can't forget to chain on negative sine x.
Which is really sine x, though. Because it's an absolute value.
Which is sine x over cosine x, which is tangent x or something, right?
That is where I'm getting.
The derivative backwards from cosine was negative sine to begin with, no?
The derivative of cosine is negative sine. So I'm taking the derivative.
And that would be absolute value.
Negative sign doesn't mean that the value is necessarily negative. Okay, the negative sign of whatever that x value is, it could be a negative value, and taking the negative and negative is a positive. These absolute value signs are really just there to protect the natural log function. You can't take the natural log of a negative number. Okay, so when we talk about the function, we have to make sure we're restricting the domain and only talking about the positive values that go in.
Okay.
Okay. We have sine x over cosine x, which is equal to tangent of x. Okay, so here it is. Backward, what's the antiderivative of tangent of x?
Negative ln of cosine x. Yeah.
Squared. Cosine x squared, isn't it?
Let's see. This is look, dude. Check it out. It's right there.
So if the derivative is tangent x,
Wait, I need my...
then going backward, the antiderivative of tangent x is negative ln of cosine x plus c. And that's the last basic rule. I will say this. A very, very common mistake that students make is they say that the antiderivative of 1 over cosine squared x is equal to the natural log of cosine x plus c. It is wrong. It's hard to understand the difference between the fact that tangent is the antiderivative of 1 over cosine squared x and the antiderivative of tangent x is negative ln cosine x plus c. There are two very different relationships listed here. Okay? So make sure you keep those relationships straight. Does that work?
The thing I don't get is why isn't there a square and a cosine?
Where?
It's like it's for the one that I said tangent x is cosine squared x. So why isn't it like the antiderivative of tangent x?
It's a very different relationship. One, we're saying what is the antiderivative of negative 1 over cosine squared x. The other, we're saying what is the antiderivative of tangent x.
Okay.
Totally different relationship. That's the common mistake that many students make.
No, but like,
So-
I get it now.
Okay. All right.
It says stand, kind of.
Yeah, it does, sort of. I do want to, let's see. I'd like to,
73.
I have no problem doing 73. What I'd like to do is this. I'd like to say these are the basic rules, and you're going to have more practice with the basic rules tonight. Over the next, Wednesday, Thursday, Friday of this week, we're going to work on undoing the chain rule, and that's not basic. That's a little more complicated. And
When's our test?
Oh,
Yeah.
God, please don't talk about
I think we're probably end of next week,
Oh.
beginning of the following week.